So last lecture we talked about subnet masks and IP addresses, and what we pretty much did was we learned how to derive the network address from the subnet mask IP address combo. Today in this lecture we're going to look at some applications. The first question type is if we were to receive two IP addresses with subnet masks, we need to determine whether or not they are in the same network. And generally what we'll find out is if the network addresses are the same, then they're in the same network, and if the network addresses are not the same, then they're not in the same network. The second question type is that we would be able to design IP addresses for a network given an address space with some user requirements. So for example, if the user required 4 subnets with a certain number of users per subnet. And you'll see a more specific example in a second. Question type number 1 are 10.10.152.3/29 and 10.10.152.12/29 in the same network. Alright, so I've broken it down to 2 simple steps. Step number 1 is that we need to convert the subnet mask to binary and then convert only the necessary parts of the IP address to binary. And step number 2, we need to compare the network addresses. Again, if they're the same, they're in the same subnet, and if they're different, they're in different subnets. So let's go on to this example and do it. So the IP addresses that we had were 10.10.152.3/29, and we had 10.10.152.3.12/29. So first, the subnet mask is /29. So what does that mean? That means there's 29 ones in the subnet mask. So let's write it out. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And so I've got 24 ones so far, so 5 more. 1, 2, 3, 4, 1. 0, 0, 0, filling in the rest with zeros. So if I was to write that out in decimal, that's 255, 255, 255, and 248. Alright, and then now we know, even before we look at these IP addresses, we know that the first part here, 10, is part of the network address. So we don't need to convert it. This part here also is part of the network address. We also don't need to convert it. And we know that the 152 here is part of the network address, so we don't need to convert it. The only part that we need to convert is this last part, because some bits are part of the network and some bits are part of the host address. So let's convert the 3 into binary. Alright, the second address that we got here is 10, and exactly the same idea. And we got to switch it into .12, so 12 in binary is going to be 16, 8, 4, that's 12 right there. Alright, so now what we need to do is identify what the network address for each one of these networks are. So we know that this is all part of the network address, and we know that there's 1, 2, 3, 4, 5 bits over here. So we're going to count it. 1, 2, 3, 4, 5. Alright, and we're going to go over here. 1, 2, count it. 1, 2, 3, 4, 5. Alright, so now we're going to compare these two network addresses and see if they're the same. And we notice that there's a 1 there and there's a 0 there. So right away, different network addresses, therefore different subnets. Okay, that's it. Example 1 is complete. Alright, and then now we're going to go on to question type 2. So Question 2 is that you're designing a small lab area for a Humber program. And this actually happened to us last week, or 2 weeks ago, by the time you're listening to this. You determine that they need 4 subnets sized 60, 36, 7, and 5 users. And Humber's IT department graciously has given us an address space, and the address space is 172.16.2.0/24. And so that means that we're able to use, what that means is that what we're able to use is any address between 172.16.2.0 and 172.16.2.255, because that's what that /24 means. That means we've got 8 bits to use as our host address. And so if all those 8 bits were 1s, then we would get 255. Alright, so let's go on to how we're going to solve this problem here. Step 1. We're going to decide the appropriate subnet mask for each subnet, starting from the largest subnet, so the 60 users, to the smallest subnet, which is the 5-user subnet. Alright, and step number 2, we're going to determine the broadcast and network address of each subnet within that address space that we're given. So let's look at the subnet sizes. So this is what we've got. We've got 4 subnets to make, 60, 36, 7, and 5. So we know that if we had a /24 address, we can have a maximum of 2 to the 8 minus 2 subnets, which is equal to 254. And if we were to have a /30 address, the most we can have is 2 to the 2, because there's only 2 more host bits available, minus 2, which is equal to 2. And so, hence, for /29, the most users we can have on that subnet are 6, 14, 30, 62, 126, and 254. So now we need to find a subnet mask that allows us to have 60 users. So /27 doesn't, because it only allows us to have 30. So /26, that one allows us to have 60 users. 36 users. The /27 is too small, so we need to use a /26. So both 60 users and 36 user subnets are going to use /26 subnets. 7 users on that one, and 5 users on a /29 address. Alright, so we've done the first part here. So second part here is determine the network and broadcast address of each of the subnets within that address space. So let's go check this thing out. And a summary of what we've done here is the /60 is using a /26. The 60 users are using /26, the /26 subnet, which means the IP address the subnet mask will have 26 ones, and when you translate that, it equals 255, 255, 255, 192. The 7 users is going to use a /28 subnet mask, which translates into, that translates into 255, 255, 240. And for the 5 users in the /29, it translates into 255, 255, 255, 248. So now, let's see. So now, in the first subnet, we need to have at least 60 users using the /26 subnet. Alright, and so we have to figure out what our broadcast address is. So our first address, our network address, is going to be that first address in the address space. So we're given this address space /24. So the first address on here is actually 172.16.2.0. However, if we were to look at the last 6 bits, because 26 bits are all those over there, so then all of those, they're all zeros. So then that address, 172.16.2.0, is actually a network address for the first subnet. So now we need to determine the broadcast address. And so what we need to do is take all these zeros and turn them into ones. So our broadcast address is going to be 172.16.2.00.11111. Alright, which is actually equal to 63. Alright, and so that means when we create the subnet 172.16.2.0/26, it can use any IP address between 172.16.2.0 and 172.16.2.63, not including 63 or 0, because you've got the broadcast address and you've got the network address. So now the next step is that we have to figure out what's the first address of the next subnet. So if that one's 63, we just have to add 1 to it. So what we're going to get is 64. So let's write that out. 172.16.2.64. So now we need to find the second subnet here. So notice we've got this address here. 172.16.2.1001000000. And so really you can either add 1 by binary or add 1 to the 63, and we're going to get either one of these answers here. And it works out. Now in the second subnet, we need to have 36 users using the /26 as well. So /26 means these bits are part of the host part of the address, and these bits here are part of the network address. We can notice quickly that the network address of the first subnet and the second subnet are different. So now, what's the next step? We need to find the broadcast address. So we're going to change these all to ones, because that's how we find the broadcast address. And we're going to get 172.16.2.011111. Is that right? How many ones? One more one. That's correct. Alright, and so now, what is that equal to? That's equal to 127. So now so that means for the second subnet, we can use any address between 172.16.2.64 and 172.16.2.127. So we can use 65, 66, 67, all the way up to 126. Remember, we can't use 64 because that's the broadcast address. The network address, and we can't use 127 because that's the broadcast address. So the first address of the next subnet is going to be, you add 1 to it. So let's add 1. 172.16.2.128. That's a 1, not a slash. And so notice these two are the same. The network address of the third subnet and the first address of the next subnet, of the last subnet actually. So where are we going with this? So now we need to now again, if you notice, the network addresses are again different. First we had 00, 01, and now we have 10 there. So there's not going to be any confusion with the network addresses. So now we need to find the broadcast address for this next subnet. However, we're using a /28 subnet here. So that means we're only going to have four bits here that are going to be able to be used for host IDs. The actual network address is all of this. Alright, so the broadcast address, we're going to make that all once. So we're going to get 172.16.2.1000.1111. So that's really equal to 143, 128 plus 15. And so, once again, let's go. So we only needed 7 users using this address. So first we started off at 128 here, and we can use the addresses up to 143. So we can use 129, 130, 131, 132, all the way up to 142, right? So now we need to find the first address of the next subnet. So we just need to add 1 there. So it's 172.16.2.144. And the fourth and final subnet, we only need to get 5 users using the /29 subnet. /29 means that only these bits here, again that's 144, sorry. These last 3 bits are going to be used as host addresses. So we're going to get host bits. So we're going to get 172.16.2.10010111. All right, and we're going to convert that into decimal. We get 151. Alright, so that means this fourth subnet, they can use addresses between 144 and 151. So we can use 145, 146, 147, 148, 149, and 150. Alright, so now let's summarize what we just found out here. We just found out that we can create 4 subnets. We need to create 4 subnets. 60 size, a 36 size, a 7 size, and a 5 size. The 60 size fits into the first address space, which is 172.16.2.0/26. And when we look at all the IP addresses that includes, not including 0, but 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 62. Not 63. 63 is the broadcast address. And then, so we can give it IP addresses anywhere between 1 and 62. The second subnet that we're going to create is a 36 size subnet. However, we can't create a 36 size subnet. The one that we could create has got 62 users, right? So we're going to create something that can take anything between these 2 IP addresses, between 64 and 128. So that means we can use 65, 66, 67, all the way up to 126. And our 36 users are going to use that space in there. Likewise, our 60 users are going to use that space in there. So now, in our next one, we need to fit 7 users in between here, between 128 and 144. So we can use 129, 130, 131, all the way up to 142. And lastly, we need to fit our 5 users here. And we remember our broadcast address just now was 151. So all of our IP addresses will fall between 144 and 151. So remember, we had space to use all the way up to 255 here from the beginning. We could have used addresses between 172.16.2.255, but we only, for our design that we just came up with, we only used 151 addresses. So we've got another 100 computers that we can expand to later on. So let's go on to how we're actually using this, how we would be using this network here, using it in a network. So if we had a router, here, and it's connected to 4 different networks, our 60 user network, 36, 7, and 5, we would have 60 users in here, and we would give them addresses over here between 172.16.2.1, 2, 3, all the way down to 126. So, oh sorry, not between 126. 62. All the way between 1 and 62. So we can accommodate our 60 users in that subnet space. Over here, we can use any address between 65, 66, all the way down to 126, because we can't use 127. That's the broadcast address. And over here we have 7 users, right? So we can use any address between 172.16.128, so we can use 129, 130, all the way down to 142, because 143 is the broadcast address. And over here, because this is /29, we can only use 3 bits, so that only takes us all the way down to 151. So our 5 users can use 145, 146, all the way down to 150. And so it has enough spaces for all of those. And that's the end of our example. Thank you.